Good. So, I think eventually maybe that's what that mural in the hallway will be. It's like these normal creatures or something. That they're all, I don't know. It's just down here, but it doesn't make it very clear that they're normal distributions. They just look like creatures on the wall. But I think that's what they're going for at least. Good. So the thing we're going to talk about today is most of the problems last night were devoid of context. We asked you what's the probability that z is greater than negative 1.3 or something like that, right? But here we want to bring to you just a couple applications. It's not meant to be difficult though. In fact, I think again, if you've either had it, which is almost all of our class probably, either an AP Stat experience this year, or you've had a County Algebra 2 course last year that did your impression, then you're going to be okay, I think, on these. You've already done these before. For people who don't fall in one of the two categories, then this might actually be, you might learn something today for you. But it won't be long and it won't be stressful for anyone. Don't worry. That's my pledge to you. So exciting is an understatement. I mean, look at this. We're talking about jet pilots and when they black out. Very exciting. So in particular, we're looking at distribution measured for the x value here, the random variable, measured in G's. Could someone just remind us what we mean by like 4.7 G's? What's that mean for those? That's kind of a physics idea, maybe. I don't know. What does that mean? I knew Ian would know, but I'll take someone else before Ian. Yeah, like I said, it's not necessarily because you've taken physics. It's just maybe because you know what G's mean. I don't know. You know, let me take Ian as the answer. Okay. Sebastian first, then Ian will fill in if you need.
The force of gravity, Earth gravity.
Okay, yeah. And what do you mean by that? So what's 4.7 G's mean?
4.7 times the normal Earth gravity.
Yeah. Yeah, so that means, I mean, normally, I guess you don't think about this very often. You don't think about this very often, but you are undergoing 1 G right now of force. You're just used to that. You're just used to that.
You're not used to it as a baby. You can't walk.
So, and then in fact, astronauts coming back are like surprised by how heavy they feel when they're walking around. They're like, really? Is this how this is on Earth? But you can imagine, if you're being pushed down, if you were like, I don't know, being launched in an elevator up, you would feel that like kind of being pushed into the floor as you go up. So that's what's happening to a pilot. To a pilot, as they drop really quickly or as they climb really quickly, they might be undergoing in those moments, or making some kind of crazy move or roll or something. In those particular moments, or even on a roller coaster, some force experience greater than that of your normal experience on Earth, by some factor. And at some point, and for some duration, you would black out under those conditions, right? Due to the blood rushing out of your head and things like that. Anyway, so it's a useful thing maybe to measure, I guess is the point, right? Like we'd like to know and talk about when pilots maybe are going to pass out. That would be important to know. So maybe really excellent jet pilots though are better. You maybe fall further down on this distribution than other people. Hopefully no one blacks out down at the left end point of this distribution. Like 1 G, no one is like walking around just like faking all the time. But I don't know. Most of us can probably stand up to 2 G to 3 G without too much trouble. Yeah. Yeah, I hope maybe I can bought you enough time to do the problem. Are you done? So we should understand what we're graphing here. Do draw a little picture. Okay. So 3.5 G's is below the mean. So it looks like we're calculating an area less than that. So this is the probability we see, and this x value here, 3.5. Let's start by G's. Let's start by also thinking about z-scores as well from yesterday. This corresponds to a z-score of something. I don't know. Did someone calculate that yet? Is it exactly negative 1.5? Isn't that nice? We expected it to be negative. And furthermore, we expect, once we calculate this probability, we expect the probability to be less than 50% already, even without any calculations at all, or even looking at the z-score. We already know that, like, oh yeah, less than this, and it's a number less than the mean. It's definitely going to come out to be something less than 50%. So good. And so now we can ask this question, right? We can actually ask, what's the probability of x being less than 3.5? Or equivalently, the probability of z being less than negative 1.5. And Ian, though perhaps others maybe are ready with an answer already, right? Did you do it already? Go ahead. Share.
6.68%.
All right, so yeah, 0.0668 or 6.68%. Daisy says, do you trust her? Did you give that to you? Okay,
Yeah.
you trust her. Good. And how did you enter that on the calculator? Just to remind us from last week, what did we do on that handout we were just doing a second ago? What do we enter? What'd you enter?
Negative, like 100,000.
Sure. I'll say what you said.
Negative 1.5.
Right, so just so you're aware, that's what she's typing in, just like we did on the handout. This is, in fact, once we get through the words, we really do have a problem exactly like what we were doing on Friday, Thursday and Friday. You can also directly do this without calculating the z-score if you like. What's the command for that? How do we modify that? I don't think we emphasized this on Friday, or on Thursday, whichever day you had me here. But how would you enter that? If you didn't want to calculate the z-score, did you figure out how to enter it? Ian?
Yeah, it's what I did the first where I realized there's an easy way. For the lower bound, put any tiny number.
100,000, negative 100,000 is, I
I
think,
put
still going to work.
2099 because there's no kill like overkill. Then you put 3.5 for the upper bound.
Sure.
Now, for you,
Yep.
right? You put in the mean 4.7, which is the third value. And for the fourth value, you put standard deviation, which is 0.8. Okay, so you use the base thing, and it gives you the same value.
And it gives you the same value. So feel free to use what, I mean, that means, do you have to calculate this z-score? I might ask you for it, and I might want you to draw a picture, but in the end, you're certainly welcome to do either one of these things, and you should get the same answer. It'll do the z-score calculation for you as well. I did include this on the slide on Thursday and Friday. I don't think we mentioned it at all. It was in brackets, so they're optional arguments. If you don't put anything in here, well, actually on the new calculator, it actually lets you enter those two things, doesn't it?
Oh, yeah.
Kind of cool, like. But the default is, if you just do this, the default is 0, 1 for the mean and standard deviation. It's a standard normal distribution, right? But if you enter the mean and the standard deviation, it'll just do the z-score for you. It'll do that transformation for you. Well, there are two maybe points to it. One is, remember, we want to still think about your weirdness factor, and I could ask you just like straight out, what's the z-score, right? It does. Now that we have like technology to help us, it makes like less sense to have to do that. I know in AP Stat they don't even tell you about this. They're like, don't do this ever. Do this, because they like really care about the z-score. Another thing that then you have to worry about this too on these. I think this is not a huge problem though. You need if say the mean is on this particular example, if this is like negative, say you use negative 100 here instead of negative 100,000. That's like sufficiently like negative infinity, isn't it? But if your data has a mean of like 1,000 and a standard deviation of 500 or something, like now negative 100 doesn't maybe feel as far away. Right? So now you have to like worry about the scale of the data. Whereas if you convert everything to z-scores, then you're like a little safer in that neighborhood. What else can I say about that?
You can always do your negative lower bound, negative 1e99.
Yeah, you're probably safe if you make it really, really negative. When else do we care about z-scores? The warm-up today. I'm trying to think, or like I said, I'm certainly allowed to just straight up ask you two-part question. Part A, what's the z-score? Yeah. So the other kind of high-level view of this too is that like all of these distributions you should understand to be the same, and you should also kind of understand what your calculator is doing whenever it does something. So what is it doing? And the answer is it's calculating the area under some curve, which is still a little bit of a mystery to a non-calculus student. But then what is it doing here? And I just want you to understand that it really is doing this for you. It's just doing this for you, and then running this. So just in the name of like understanding and sense making, which is like the entire subject of what we do in math, in the name of making sense of things, we should at least, at the very least, explain what your calculator is doing when you do this, even if you do use this command. But we're certainly allowed to ask you for a z-score. Just as practice, would you run those two for me? And then as like a part C, now I hesitated to put this on here, but I was wondering what, maybe some of you do remember your birth rate though. So if you remember your birth rate, it'd be fun to kind of calculate what percentile were you. There are 16 ounces in a pound if you know how much you weigh. And we'll just, there's nothing more to add on this, just an extra problem to practice with. So we'll call on someone randomly here in a minute or two. Get all of these. Do you remember your birth? Does anyone know? I don't know that. I should know that.
We find the probability of getting less than 124 and then subtract the probability of less than 108.
That would be a fine way to do it. I think there might, your calculator will allow you to do that quicker though. Are we getting good with the calculator command? We figured out how to do this on yours.
Like I can do stuff still, but like if you use anything new, then I'm like, oh, you're right. Yeah. I didn't figure out that you had to like switch up about it.
Not for today, at least. Not for today. Tomorrow, you will check yourself by realizing how to do linear regression.
I don't even know what a linear regression is.
Figure out how to get your R and R squared to actually do residual plots. Some of those things you might want to look up. Do you remember your birth weight? Okay. All right, let's just get the answers on those two, and then I do want to hear from some people what the answer to C is for you. So, Ananya, on the first one, what'd you get there for A? 0.459. 495? Cool. Sorry, I gave away your seat. You can sit elsewhere. You can sit. How'd the AP Calc test go?
It's actually 38.29. That's not the four.
Eric, what'd you get for B? Eric? 0.3383. Can someone confirm those? Yes? Okay. And does someone know their birth weight that can offer, did you do the calculation? You nodded yes, Passy. Okay, you're like on the larger end of babies. Okay. I mean, whatever. That's good. That's good and healthy for a baby. You're like an overweight baby. That's good. So what does that come out to, Cassie? How'd you rank then? What does that come out? What does that push up? You didn't calculate. So 16 ounces for each pound. So you can do the conversion. Yeah. So. Is that exactly as easy? Did you calculate your percentile again? 128. So that's 80. You're in the 84th percentile. I don't know. Anyone else do theirs? Any abnormally large or small babies out here? Anyone? No one of you know. Maybe no one. All right. Let's do a pretty low key day today. We got one more example. Stay with me here, and then I'll let you have an early crack at the homework here. Okay? Can you turn your attention to this problem? And in each of these cases, let's draw a picture. Okay? I think that would help you in analyzing these. Okay? Draw a little shape, something. Make it clear what in your mind what you're calculating. So, what do you think? Alright, well, we'll mark you on the sheet. So, don't be, well, I would mark you, like, I would mark you as, I would better than you based on that's not these things. But I don't How are we doing? So,
Not what I got. Okay, good. Because I was like,
did you draw a picture? Be careful, draw a picture. I see a lot of wrong answers, even from my AP stats students, right? Draw a picture. Make sure you're thinking clearly about who passes.
I made a mistake. It's 420. Yeah, 551. This is like first.
All right, yeah. Be careful with the picture here. Thank you, guys. Let's come to order. Do you want to, I don't know, do you want to walk us through it a little bit? Vivian, what was your thought process? Oh, you did it wrong? Okay. Well, then you're the perfect person to talk with humility about how to do it properly. Okay. Oh, you don't? Oh, okay, you're not there yet. Okay. But you're right, it's easy to like start drawing pictures and not have any understanding. But let's make sure we're thinking clearly about which direction to go. I think a lot of people eventually did get it right. So yeah, do you want to explain, Ivy? I think I like your picture.
So, if 70% pass the revenue like to the right of whatever the score is, that's 70%.
Yeah, so this is the picture. I'm just reproducing her picture from her paper. Looks like this. Do you agree that the people who pass are over here? People who fail are over here? Okay. So this is, she says, 0.7, which makes this, if you care, 0.3, which maybe we do care. All right, so go ahead.
And then I did in this score 0.3, but I did one.
So she used this command on the calculator. Point what? 0.3. And if you do that, then you get a z-score, I guess, where that is. And I don't know, you could tell me that too. It's negative something. You get it? Or no, or you just run it with the mean and standard deviation. Negative 0.524. Others can confirm that maybe. So that's the z-score. And then if we have the z-score, then how do we get the value? I don't know if we've spent time like going backwards on these, but this is kind of, normally have the value like the z-score. This is actually maybe the more natural direction to go though. Yeah.
You use the z-scores, you know, that's how many standard deviations away it is, you multiply it by the standard deviation and then add it to.
Yeah, and I think that makes just intuitive geometric physical sense from the picture. If you have a z-score of negative 0.524, what do you mean? Well, you mean that you're like half a standard deviation below the mean, right? So what he said, multiply that by the standard deviation, and then go that far away from the mean this way, right? Anyway, when you do that, you'll get something. 447 point something. So I don't know. What do you want to say? The 448 or something? Maybe they give half points. I don't know. And then for those who like shortcuts, like Fatma here, what's the way you get that immediately? I was actually asking, but it's okay. Go ahead, Fatma.
You just put it in the calculator with 0.3, but also you add the 500 and 100 to represent the mean.
And then does that give you that right away?
Yeah.
Right. So that's fine too. Just keep in mind that you understand like what's going on under the hood too. Okay. So just like in the same vein as like me making you think about and understand the standard deviation calculation or the how to calculate the expected value by hand if you needed to, you understand under the hood what's happening. I also permit you to use the full force of the calculator for these tasks. But at any moment we should be able to slow down and like understand what's going on too. So let's do both. Let's be lazy, but also when you push, be able to go deep. Okay? The real question answer. I have ways of asking these questions, right? I can ask for a z-score if I want a z-score, but yeah, I think the calculator test is all to answer your question. Would you like your homework?
Yes.
Bro, I did not do well on that. I think I said
All right, on. All right, someone just asked again about the date of some things that are coming up here. So we're gonna move the IB problem to Friday and the test to Tuesday. So that's a little different, not that different, but a little different than what's on your calendar. So put those on the calendar. Hopefully we're like avoiding next year. Thank you for that clarification. The main reason I'm putting it on Friday